All right, this is a jam. What do we got here? Cool, cool, cool. All right. Where do we leave off? Let's get some data. Everything still works. Nothing broke overnight. Cool. Last 5 minutes is good. Do we have anything? It'll be empty. Oh, there's something. Sweet. Okay, this works. This is working now. Come on. Sweet. So, I have all this stuff coming in. We have to get this into a readable format, and then we also have to... Ooh, what's going on there? 150 and 200. Okay, let's double check that. Non-loaded. Is it actually non-loading? Okay, that's good. I have to edit my NeoVim. All right, now it doesn't bug me, at least anymore in startup. Okay, so last night we got all of this data into CloudWatch, which means we've got like a really good view of sort of the curve of latencies that can exist when you're building and deploying Lambda functions with various amounts of dependencies. So we should have the exact configuration, the same exact node modules in each of these two, top and bottom, with the only difference being in the bottom row, we're loading them all. We're like requiring or importing them entirely. And with the top row, we are not loading them at all. They just happen to be in the zip. We can definitely see that there's a difference between, so I'm looking at average right now. We can switch that to P99 if we want to. we can definitely see that there's a difference between a 0 megabyte function and a 250 megabyte function, which is, I've learned from folks at AWS that that's expected because init duration does not count the time taking to load the contents of the zip file into the micro VM. So those bytes are copied or mounted using their file system, but that takes a non-negligible amount of time. However, as you can see, the difference between the bytes you load and the bytes you don't load is staggering. So there's like a lot of, I think, key insights we can get from this already, right? We know that if you're going to, say you're deploying like a Next.js app or like an Astro app or something, React or whatever, and you have like what kind of a mono lambda, like a number of routes in your function that are serving many different routes of your API, but you don't need them all the time, you can lazy load them and effectively get a really significant, cut or discount to your round trip cold start time, which means that instead of loading 150 megabytes of dependencies on every single cold start, if you don't need them for each route, you can potentially shave 1.5 seconds off of that cold start time if you don't need all of those dependencies. So I think that's already like a really cool takeaway. What I want to do today is replace this API gateway that I've hooked this service up to with a cron job, and then run this over and over. Last night I was talking to Jay, the developer from New Zealand, who had mentioned that he thought it would be fair to do like 2,500 tests per day for a week before we kind of were conclusive about that. I think that makes sense, and also a test running for a week is convenient for me personally because I will be in New York next week. So, all right, let's do this. So we want to go to the invoker. Oh no, I have a swap file. What did I open this with? Oh, it's right here. Okay, already got it pulled up. Hopefully everyone can see this. Maybe it's even too big. I can make it a little smaller. Sweet, okay. Awesome. This is going really well. I'm just quite pleased with what we have so far from this. So instead of the configuration coming from the request payload, it's now going to come from a cron job, which means there won't be an event body. So what do we need? We can do this a couple of ways. We could try and be smart about this and like look at all of the functions in my account and maybe like filter by a tag. That could work. Part of me just wants to hardcode these in an environment variable. Let's do that. So environment, function names, and then this is just going to be a long list of function names. What do we got? We have the curl command. Okay. Okay, yank those, paste them here. That should be okay. The quotes should work. Actually, we shouldn't even need the quotes. We should just split on... Do we want to split on space or comma? Comma space? I guess comma space is already in there. Yes, I could write a regular expression for this, but I've got it already pretty much done. I do so many Vim things not Vimy. I don't know what playlist I found, but I'm liking this. Okay, that'll work. That'll work. So we don't need this HTTP event anymore. What is it? It's event, or is it cron? What the hell is it? Serverless framework. Schedule. Oh, it's scheduled. Duh. Should we do this just once a minute? And what do we got? Let's just... So when I have to use a bunch of environment variables and I forget how all this works, I'm just going to open a node console. What do we got? Function names equals boom node. Const let names equal process.env.function names dot split. What does that give me? Names. Hey. That'll work. All right, so we can just grab that. Oh, cold start. I think we want cold start to be always true, so I think that's fine. Oopsies. So this is a holdover from API gateway times. Okay, split, oopsies. Split this. And let's just set cold start to be true. All right, give it a rip. Uh-oh. Must be an object. Functions invoke environment. Did I not? Oh, yeah, duh, it's not an array. Sorry. These are named key values. That's better. Oh, sorry. I just realized I cut this off a little bit on the stream. Cool. Get this deploy out, see what we get. Then I think we can probably call this portion of the talk done, which is definitely the hardest part. I don't think anyone's really done this end-to-end for a long time. The other thing we do want to look at is the CPU available in a Lambda function during initialization, and maybe that's something else we can look at, because I don't think anyone's really looked at that since Michael Hart did a while ago now, and I wonder if that changed. They make, you know, no promises of what you get during init. But first things first, I need to be more disciplined about finishing what I started. Boom. I shouldn't be signed out anymore. I should just close these and we'll reopen them when we need them. Cool. Okay, so hopefully, okay, last event, that was back when it hooked up to an API gateway. Now we'll be using CloudWatch events, so we shouldn't see any API gateway anymore. And that, I think if we curl that endpoint, it should be gone. Yeah, I couldn't resolve host. Okay, sweet. So that worked. Now we wait 1 minute. Oh, it just invoked. Uh-oh. Cold start's not, oh no. Shoot. I knew I would do that by just passing a Boolean. Oh, that's my own fault. Why would I do that? Const cold start equal true, because I need to use it later. Yep, of course. I put it in the response, and I don't actually need to return anything because there is no response to return. And let's log. All right, try that again. That failed miserably. as all good first attempts do. Come on, CloudFormation. I wonder if it's slow on a Saturday. There we go. All right, we're gonna get another one, 49.10. So it should be coming here in another 10 seconds or so. Come on, you can do it. At least we got data out of that cron, all right? We actually got a response, which is good. Because it was able to update that metric, and we can look too, right? Last, what did we do, 5 minutes? I need to double check the 50 and 100 megabyte services. Both of these are a little confusing, and I wonder if I swap them somehow. Everything else is looking okay. I think in the fullness of time and many repeat tests, we'll see a better response there anyway. Or like a more clear distinction. There we go. Uh-oh, it ran twice. Did it fail? No, it didn't fail. Okay, good. Why did it run twice? No idea. Interesting. And there, yeah, totally different log group IDs, so different requests. I wonder if cron's not guaranteed to be idempotent. Okay, so while this is running, I want this to run just for a while. Let's go back and do bun. Let's, okay. I want to actually update the title. Let's do that. Because we accomplished the automation. Okay. That is updated. That's great. Let's add bun. Bun dev. I think that's what it was called. Should we go and look? Bun. Where's, oh, it was, bun experiments. Is this it? Oh no, it's bun. Where did I deploy bun from? Bun lambda. Oh, right. There should be a git file here. Okay, so hold on. No, where did I? Lambda bun container, thank you. And I don't think this is right. I think the source IP is always gonna be my request IP, so I don't even want to do this anymore, but. And serverless bun app, adjust this. Remove the, remove this. Oh, and we should return handler TS and then date.now. That's what we need. So by doing this, and we can straighten this out. Ooh. Should just format on save. By doing this, we're gonna plug straight into that adapter, so we'll get to see what the response time was from the handler when it runs, which is good. Oopsies. Oh yeah, Docker build. There we go. Docker build, Docker push, Docker run, or whatever. What? Oh, login. Always helpful to log in. What? Why? Okay, so this is why I've been fighting with Docker, because I think the last time I had to do this, I had to kill Docker completely and restart it. And that's frustrating. Docker daemon shutting down, reopen, come on. Restarting the Docker engine. Come on. All right, is that better? Is it done? How about that? Hey, look, see, killing it and restarting it works. It's so frustrating. This is why I think I tweeted last week or this past week that I want to switch. Oh, man. How do I do this again? Docker log in. So let me pull the container, but now it's not letting me push. What do you mean? AWS Docker logger. How did I fix this? I've done this though. All right, we can run this, but I want to. We got to go into the secrets. Secrets are no fun mode for this. Is that working now? Hey, we're pushing. Okay. There we go. All right. Whoa. Oh my God, Melky. I had 0 people in here. Thank you, Melky. Thanks for coming. Thanks everyone who's tagging along. Oh my God. I don't think I've ever had... Everything just exploded for me at once, and I don't know what was going on. I've never had this many viewers. Yo, thank you so much. Yeah, 0 people stream. Thank you so much, Milky. I really appreciate it, man. It means a lot. Welcome, Melky's viewers. I gotta screenshot this. I've never had this many people on stream before. Thank you. We're working on Bun in AWS Lambda right now. We found the fastest way to do this is with a Docker container, or I'm sorry, a container image for Lambda. Yeah, MDark. Okay, I've never caught up with. I've never been able to keep up with chat like this before. This is crazy. Melky, thank you, man. I really appreciate it. What are we doing? Okay, so AWS Lambda is an awesome serverless service that you should be using. And if you don't know about it, you can learn a lot more on my blog or on my Twitter feed. I think, is it ! blog? I don't know if I have it in there yet. No, okay, I need to add commands. I'm bad at Twitch. I'm really sorry about this. Let me grab the link. So I used to work on this tool called the Serverless Framework, which we're using to create a bunch of benchmarks for Lambda. Lambda is a way that lets you upload a little bit of code to Amazon Web Services, and it will just execute it for you. So you don't have to provision a server. You don't have to manage updates. You don't have to install any kind of dependencies other than your application. So what you can do instead is kind of snippet this code into AWS Lambda, and then you can run it whenever you need to. We started the stream a couple of days ago with API Gateway connecting to Lambda, which then invokes a bunch of functions to measure the cold start time. But what we're doing now is we are using a cron job to do this over and over again every minute. So we're collecting data. Hey, thanks for the follow. I really appreciate everyone dropping follows in here, man. This means so much. Melky, you're too kind, man. I really appreciate the raid. That's crazy. Everything, like all of my notifications and all of my alerts just exploded at once, and I had never seen anything like it. Thanks everyone. Back to the project. So I'm giving this talk at reInvent. reInvent is AWS's annual conference in Las Vegas, Nevada. It's like after TwitchCon, so I won't be at TwitchCon. But I'm giving this talk, and it's all about how to improve the cold start time of Lambda. Lambda is amazing, but one of the kind of tough things to manage if you're getting used to it is that it scales on demand. So when a request comes in, it'll initialize a new environment if there isn't one already ready for you. And that can take a little bit of time. And for some people, that prevents them from using the service at all. And that's what I want to be able to show folks. You can manage this, and you can make your cold starts really fast and sort of thaw them or tame them is what we've sort of been calling it. So yeah, Bun initially, when they released it, they published it as a Lambda layer for people who wanted to use it in serverless, and it fell all the way to the bottom of the benchmarks for cold start time. But what we learned is that using a Lambda layer, the caching mechanisms aren't quite as good. So if you're interested in Bun on Lambda, running it in a Lambda sandbox puts us way back here in the Python runtime, Python node sort of realm where we get those 100 millisecond, 120 millisecond cold starts. So did a bunch of these tests, and they're a little, I should say that 120 is at the low end for sure. But so what I'm doing is I'm just creating this like serverless application, just written in Node, written in JavaScript, that can ping all these different Lambda functions and cause them to cold start and then measure how long it takes for that to come back to us. So we can then improve and sort of monitor and understand how to improve the performance of our applications. I'm also more than happy to answer questions about AWS or serverless or any questions you have about the industry too. I work at Datadog now. I'm a staff engineer there, but I've been in the industry 11 or 12 years now, and worked at startups, worked at big companies. Happy to answer questions. I don't have a Discord either. You can find me on Melky's Discord. And I really appreciate the follows and everyone coming in and chiming in. Thanks so much. Let's keep burning through this then. So first off, based. The very first cold start takes a while. We know that for sure because this container image doesn't live on any of these servers yet, so it's getting pulled in dynamically. But further cold starts are really, really fast. And actually warm starts are insanely fast. So we can see how much faster that one is. But now we can cause a cold start and actually get the data back. And I'll show you what that looks like. This is the AWS console, and you all now can use it because it has dark mode. So it's not going to blind anyone. If we pop open Bun, actually, is this one modified 5 minutes ago? Okay, good. This is the right Bun. So one of the ways you can cause a cold start pretty deterministically is to just change an environment variable. Oh, I think I have a bunch of dependencies in here. Okay. Let's figure out what this is. So this should be another, like a little bit longer once, oh, sorry. This blue bar goes away and then it goes green. Now we're ready to go. And we can see there's a little bit longer cold start, a little bit longer delay, but not nearly the same delay that we had in that very first one. We can actually find out what they report the cold start time as, but our service will do this automatically. And it will actually measure round trip time as well as like the initialization duration. And one of the things we learned really early in the stream is that if you are a serverless developer and you're just like in CloudWatch logs, yo, thanks for the follow. Is it Baker Dev, Biker Dev, BKR Dev? I appreciate it. Thank you so much. So if you're just looking at this iteration, you're not seeing the whole story. Python better than Java on cold start. Good to know. Yeah, it is. It's a great point. And furthermore, it also consumes a lot more RAM on the cold start side. So you can actually swap pretty heavily and experience even slower cold starts. Depending on what you're loading. Wow, thanks everyone for following. It means a lot. I really appreciate it. I just started streaming a couple weeks ago to work on this talk. It's been really fun, a lot more fun than I thought it would be. It's a great way to force myself to do a bunch of data collection and talk to you all and hang out, which is a lot of fun. Oh, I can't even keep up. AKS512, thanks for the follow. Mo Tan, thanks for the follow. Shulden following, and Stabin Soup. I can't even pronounce these names. Thank you all. Appreciate it. Got my Plant Dad cup here. Just having some tea. Podcast, thanks for the follow. Yeah. Okay. So back to the project. If you're just looking at the cold start time reported by your log group here, like in terms of an iteration on Bun, where did Bun go? Yeah. If you're just looking here, you're seeing a good representation of how long the binary takes to start, but you're not seeing the time it takes those bytes to load by your sandbox. And I think if we start to keep track of this and keep an eye on these values, what you're going to see is that container-based images and custom runtimes like Bun are actually a lot closer to the performance level to our native runtimes, and that is huge. So I think this value is totally true on like that very, very first cold start. Captain Luffy, thanks again for the follow. Yeah, just started. I think this is probably my 6th time or 5th time streaming. But anyway, so I think if we keep a close eye on the round trip time during a cold start instead of just necessarily the init duration, which again does not include the time it takes those bytes to get into the micro VM sandbox, you're going to see that you can deploy a lot more things on Lambda than maybe you thought, which is what I want to sort of encourage viewers to think about. So many people look at Lambda and see an init duration that's long and think it's a cold start that's like too painful and rule it out immediately, without realizing there's a number of ways to manage these and keep these small and keep these fast. So many techniques to do this. I've written a lot about this. If you are using Lambda today and want to find out more, there's kind of 2 big advantages you can do. The first is you can benchmark the loading time of your libraries. I did an example with the AWS SDK here, and what it does is it's very similar to what ESBuild's bundle visualizer does, but it does it in real time every time you generate a trace. So it'll walk, when you require AWS SDK, it's not just one file, it's like a tree of files. So each dependency can have more dependencies and so on and so forth. So we can actually walk those and measure how long each of those take. And you can then get that on like an APM flame graph or like a profile. ESBuild does this too. What is it? Visualizer? Definitely check this out. Bundle size analyzer. So I'll plug this in the chat. If you're using ESBuild, if you're writing TypeScript, or you're building, a Next app or a React app, you can import your meta file in this app, and it will tell you the exact same thing that I just showed. It'll give you a flame graph of how many, instead of the time to load, this will tell you how many bytes these are, which is a really good way to identify ways to cut down on load time. So if you're new to performance engineering, if you're new to building on the cloud or building Lambda, or you're a student and you're trying to pick up some of these techniques, understanding the impact of the dependencies you're bringing to production is like a great way to kind of level yourself up too as a software developer, because not many people think about this and they put just so much stuff into their node modules without realizing like the impact here. Dalton Soft, thanks for the follow. So back to Bun. Oh, and if you are struggling with cold starts, there's a technique I laid out here that is well represented by this data. I can plug this here. The technique is just called lazy loading. It can fight a little bit with your bundler, but the advantage is shown here in this metric table. So this is the culmination of the last few weeks of effort. What we've done is we've created 6 Lambda functions with 0 to 250 megabytes of dependencies, and then 6 more where we have the exact same dependencies, but we load every byte in those node modules. We just import everything. We can see for 0, they're exactly the same, right? 300 milliseconds or so. But on the high end, if you don't load any bytes at all, but you just put 250 megabytes into your zip file, it loads in about 462 milliseconds. But if you load every single thing, it loads in 3 seconds, right? So that's like 6.5 times slower if you load every byte. With that in mind, we can take advantage of that. And we can say, as sharp engineers, we can say, hey, if I don't need this dependency, I'm going to load it only when I like right at the time I need it. And especially if you don't need it for every request. So the example I laid out is a common one where you have like a special customer in like a multi-tenant, SaaS application where they have a demand that's like, hey, no, you have to send me an alert via SNS if this request comes through your API, right? Or like push other data to me so I can, whatever, denormalize it, share it with somebody else, that sort of thing. in that case, you can actually not even load this code until that request comes through. And that's an advantage you can get. In this case, it shaved like 50 milliseconds off the cold start time. But you can see the higher the dependency in megabytes, like the larger it is, the better that works. So yeah, now what we have to do, what we've been doing is automating this. So let's refresh it. We should have 5 more runs of data because it's running every minute now. Hey, that's a little better. And then we need to get Bun in here. So let's get Bun. First thing I want to do, is there, Emmer, hey, welcome back. Is there any difference between using HTTP and path in the serverless framework and HTTP API and route? Yes, big difference, big difference. So if we look at the serverless Bun app, HTTP API is API Gateway v2. And I want to say it's twice as cheap as API Gateway v1. There's different pricing levels for this. But if you use HTTP, whoopsies, this is API Gateway v1 or a REST API. And HTTP API is called API Gateway v2 or HTTP API. It's just significantly cheaper in cost, but it has a lot less features. So if you're using request mapping, if you're remapping data in your API gateway before it hits a Lambda function or hits a, even like a server running in Fargate or an instance in EC2 or whatever, then you kind of need that feature. Otherwise, HTTP API is a lot cheaper. They're very similarly ranked in performance though, like within a couple of milliseconds in my experiments. So it shouldn't matter too much. So you could do this. Both of these have free tiers. So if you're new, first off, if you're new here and you get a surprise bill from AWS, I want you to DM me, reach out. AWS is really good about correcting those types of mistakes, and I can help get you in touch with the people that can help make that happen. My very first experience with Amazon Web Services was in college, and I spun up like a Microsoft SQL Server instance and left it on and forgot about it, and I got like a $400 or $500 bill. This is a long time ago, so it was pretty horrible, and I had to like email them and beg them for my money back because I wasn't going to make rent without it. I once owed 150 grand to AWS. Yikes! I don't think I've ever personally owed AWS that much. Since then, AWS has been a really good partner to work with. I really like being a part of their Hero program. I'm a ! Hero in chat if you want more information, but they have this program for people that have, contributed in open source and contributed in like technical writing, those types of things. And they're called Heroes, and it's a really nice way to recognize folks. And I was just added to that group in June. You got it resolved. Okay, that's good. I'm really glad. And yeah, like I said, if you're like a student, or if you're a student, you should definitely sign up for the entirely free AWS education. So there's an entirely free program where users as young as like 13 or something can learn on an AWS console without ever using a credit card, which means you'll never get a bill. You should absolutely use this program. I'll plug this in the chat. If you're brand new and you want to learn about the cloud and you want to level up your career learning AWS, this is the way to do it to guarantee you never get a bill. If you are picking up AWS, as a professional that's trying to learn, you do have to sign up for a normal account and put a credit card down. But there is a really generous free tier, and one of the ways to kind of keep within that free tier is to stay within the serverless offerings, because a lot of these, as you can see, are always free. So Lambda, always free, up to 1 million requests per month and 3.2 million seconds of compute time, which is great. I mean, you can run like a really big application for like as a personal developer. You can run a really no. These are okay. So AKS is asking, it's free for the first year. No, these are always free every year, no matter what, forever. And that's why this is one of the reasons I really like telling young folks and new developers to pick out AWS serverless, because you can stay kind of in that free tier forever. The exception is API Gateway, and this is where it can get you, where after a year that starts to be billed. However, with Lambda, you now have the option to use Lambda function URLs, which are always free. So they fall back into that always free tier. So you can deploy an entire API or like an entire Next.js app on top of Lambda and S3 and AWS and never get a bill for all of your enthusiast kind of work. And I don't think I've ever gotten a bill on my personal account. I've got a couple of credits and some money back. Yeah, so you do get, okay, so AKS is saying they got a bill. Yes, some services like EC2 are only free for the first year. That's why I suggest if you're gonna put compute in your application, which you need to at some point, definitely start out with the serverless stuff. Step functions, Lambda, SQS. You can build a huge app with SNS, SQS, Lambda, DynamoDB, all for free, all forever. Dynamo, totally free, right? 25 gigabytes you can write to Dynamo, and then you get 25 WCUs and 25 RCUs, which are more than enough for most APIs that you're going to run as a hobbyist. And it's a great way to learn the cloud. So highly recommend this. If you do unexpectedly get a bill, the big exceptions right now are Bedrock, which is their new AI platform. I don't think has a free tier, and like SageMaker, which is kind of their AI training and inference ground. They're really expensive to run, so they do bill for those. But definitely, if you get a bill, DM me. I'll see if I can. I can definitely get you in touch with the right people that can help make that go away. Unless you're a big company. I got a DM once from an actual like venture-backed company. I'm like, didn't you just announce a $30 million funding round, and you're asking me to help you get like a credits back that you accidentally spent? Anyway. Yeah, absolutely. Turso, PlanetScale. I would plug Neon. I love PlanetScale, first off. Mad respect for the hat. Sam Lambert hooked me up with this. Or I don't know who. Someone else at the booth at reInvent last year hooked me up with their hat. Love the PlanetScale hat. Great job, y'all. I also like Neon. It's a great database. I have a really good friend who works at fly.io. They have a really good product too. So there's lots of options out there. You just got to read the manual just a little bit. Just a little bit of reading. So yeah. Set billing alerts. Yes. Oh, okay. So we can talk about that too. On this account, so right now I'm logged in as a user that doesn't have any permission to see a billing dashboard. I did that on purpose. So yeah, this is like, you don't have permission. So I have a different account that has billing permissions, but I have a billing alert where anything over 50 cents will send me an email. I recommend you set those up right away. Actually, is that something people would be interested in seeing? I can show y'all how I protect against bills on AWS. I can like jump in. You can also, again, I don't have permissions here. I'm using an IAM role, but you can see what you're using within the free tier here. Haven't tried Neon yet, looking to Turso. Neon's great. Okay, sure. Let me log in quick. I'm going to just pull it up in a different window. So I have to log in as my root user now, which is a little scary, but that's fine. And always put MFA. So that's the first rule of this is always MFA. Always MFA. The first thing you should be doing, set up MFA on every account that has to log in. I'm doing this kind of the old-fashioned way. All right. So I'm logged in as my root user. Oh yeah, this is public now, so I can stream this. Amazon Bedrock is GA. So okay, let's go to the billing first because we talked about that. All right, so how long have I been? I've been running thousands of Lambda invocations in a loop for the last like 3 days, and my current forecast bill is 3 pennies, and that's from probably Amplify, which is their front end framework for Next.js. Little Dynamo in there probably. So the first thing you do is you separate your accounts. The second thing you do is you go into here, you go to billing, and you go to alerts. Where is this? Bill alert. Budgets, yeah. AWS budgets. Oh, it's right there. Okay. So I have an error that's called too much AWS. Today, okay, I set it at $50 because I figured I would spend a lot of money on this project. So you click create budget. You can use the template simplified. This is great. Zero spend is amazing. Feel free to hit that. I usually just do like, monthly costs and set it to some amount. Because again, I'm expecting to spend some money. I know I'm using features outside of the free tier, but go in here, hit this button, and hit create budget. You're going to get an email. If you have other emails you want to get, that's totally fine. If you want to be wild, you sign up for a free PagerDuty account and you page yourself via email if this goes off. The downside of these alerts is that they can take like a couple hours to process. So if you accidentally leak keys in like a GitHub repository and someone tries to spin up a bunch of resources with those keys, you can get a little bit bigger bill. And even then, one thing they do is they scan GitHub for anything that looks like an access key. And that's why access keys, key IDs have AKS in front of them, or AKID. So they're very easy to find, and they kill them immediately. It's pretty impressive. If you haven't done that, you can commit something that looks like an access key to GitHub and watch how fast like you get an alert from both GitHub, and then if you actually use a real one, it gets shut down really quickly. However, I wouldn't suggest you actually use a real key. If you do, maybe create type permissions, which is a good segue to the next part. The number two thing besides a budget that I see people goof up a lot, not going to try it, thanks. Yeah, please don't try it. Oh, thanks, Lo. I believe in me too. The other thing people do here is they create one user and they use it's called the root account, and they use it for everything. Don't do this. I logged in with my main account, but you can see in the background here, I have this personal account. This is me accessing certain resources as a logged in user to the console. You can see I have MFA, so you can create a new user for yourself, and it will tell you if you want a management console or not. I create two. I create one admin for my CLI, which now you can use roles for, which is even better. When I set this up, I don't know if I did, but yeah, 4 years ago. You create one CLI role, and in my case, I use access keys. You should use like AWS SSO if you really want to be serious. Access keys are probably okay though. And I use one role for that, one user for that. And then I create a personal user that can access the console, and I create MFA with that user, and then I log in with that user. So now I don't have to worry if my credentials that I log in every day get leaked on stream. It's no big deal because I can just nuke that user, or I can revoke those permissions immediately. And even then there's MFA, but regardless, this protects me a little bit. And I can also limit the access of this person. So if you want to help yourself out, if you're saying, look, AJ, you're right, maybe I should just use serverless services when I'm learning, you can go in here and say, okay, you know what? What permissions do we want to give? Maybe not administrative permissions, right? Maybe what we do is we just give permissions to create Lambda functions. So you can, attach policies directly. You can create a new group and say, I just want like Lambda, right? And this is complicated because you actually need a kind of a fair bit to deploy a Lambda or like a serverless service. But you can give yourself full access just to Lambda and then say, okay, this is great. Now this user can only deploy and destroy and mess with Lambda and nothing else. And that prevents you from those like somebody spun up massive, R4XL database instances and cost you a bunch of money. So those are two things to do right away. You create your account, you create a new user, you set up MFA for the root account and for your own custom user. And then you go to that billing dashboard and you set a $0 budget bill. And if you're going to be out of the free tier, maybe you want to spin up a database, or you want to, create a load balancer, or if you're all are Melky's viewers, which I still appreciate hanging out. There's a whole bunch of you still here. You want to use the RAG stack that he's been working on, like that may have some cost built in. And in that case, you can set a budget for like a little higher, what those costs are going to be. And then you're set, and then you can just rock and roll, man. Cool. Yeah, it's a quick walkthrough of how I set up my AWS accounts when I first get set up. I just checked. I have a super old domain route DNS thingy around. Yep. Yeah, that'll happen. You can totally export user policies. You can definitely do that. There are a couple already that are like just for, only for serverless services or only for free tier services. And you can even set an alert that's like, am I close to the free tier? So if you want to check Lambda and say, okay, I've got, 800,000 invocations this month, then I'm 200,000 away from the limit. Maybe that's a good thing to do. Up until recently, the thing that got a lot of people was creating an infinite loop of Lambda functions, which I had done a lot on accident, and I racked up a pretty solid bill for one of my companies. That is now automatically stopped by AWS Lambda. So kudos to that team. Good work. That's a big improvement, and they did that using X-ray trace IDs, which is pretty clever. All right, I want to remove Okay, good. There's nothing else in here. Yeah. Okay, Docker, big Docker command. We're going to build, tag, and push that container image. And then we'll redeploy it, and then we'll plug it into the invoker service. We should do that here. This is cold start benchmarker. Hello invoke. What's the name of this function? Okay. There's a few other things here that we chat about. When I'm using the serverless framework or any kind of serverless application builder, always give an environment name in your stack or in your function so you know, because it's super common to deploy copies of your infrastructure in the same account or in the same region, and you want to be able to differentiate. And you also can't have a name collision, so sweet. Okay, that worked. And then we go to, so this is the app that includes this container image in ECR and runs it in Lambda. If you're brand new to Lambda, but you know, or you have an app in Docker already, one thing you can do if you want to try out Lambda is you can drop it into Lambda and use this. This is a Lambda extension that AWS wrote called the Web Adapter. It's written in Rust, which means it's good. And there's a lot of familiar faces on this contribution list. It's a Rust project that gives you the web framework model you're used to, right? Like expose Docker serve like on a port, and then it will use the AWS Lambda extensions API to invoke your function, which means you don't have to worry about modifying your code to be a like Lambda function compatible format, which is just a couple of odds and ends. It's not too hard, but this is like a drop-in feature where you can literally take a Docker container or OCI image and put it right into Lambda and serve it just like you would on your laptop. I can plug that in chat. This is a great thing to have. Okay. And this is the serverless framework. This is what I've been using to build these. I used to work here. I was the principal engineer on this project for a number of years, or an engineer, I guess you'd say, because I got promoted at my time there. But you can learn a lot about serverless through this. And one of the questions we were talking about was REST versus HTTP API. You can see the difference right here. Faster and cheaper than V1. Okay, we're deployed. That's great. Now it's time to modify our cold start benchmarker. So I took a cheap route when I started the stream today, and I just dropped these all in an environment variables. I think that's fine, actually. Just put the bun app there. All right, we'll run that deploy. Thanks again, everyone. Rating from Melky. If you haven't, hit that follow button. That really helps me out. I appreciate it. Let you know the next time I stream when I'm working on this stuff. If you're interested in serverless or you have questions, feel free to drop them in the chat. If you're just tuning in for a little podcast episode, feel free. I'll try to be interesting but not intrusive. Cool. Okay, so I've got all these functions flying around. This is the other thing that I like about serverless is I don't have to pay for any of these. I've got, what do I have, like 29 functions here, 30 functions? 30 functions I've got, and I'm not paying a dime until any of them run. Who is Risky? Thanks for the follow, man. Appreciate it. So they're free to just upload and you know, keep in there, and when you use them, you pay for them. When you don't, you don't. So if this works, this is the automation. Now we're testing the automation. A brand new metric should appear in this browse option after this runs the next time. So it's running every minute. Every minute it's going to cause a cold start on all of these Lambda functions. And then it will report back the duration for the request to go to and from that service. So we'll grab, hopefully what will show up is a bun function name will show up. You can take a look. And if you haven't seen this either, my friend Max wrote this tool. You've probably seen this. This is the cold start benchmarks run daily, so you can kind of get an idea. Rust, very, very fast, of course. Go, very fast. Swift, not so bad, actually. Python, really, really good, too. Don't sleep on Python. I know I'm kind of writing a lot of JavaScript now. If people are interested, I can I can write some Python. Rafaz110, hey, thanks for dropping in. Asking, how do you force a Lambda cold start? Great question. AWS Lambda's API has two main options to update a function. You can update the function code, and you can update the function configuration. Updating the function code is exactly what you'd think. That is when you go in here and you change something in the code source. This is too large, so you can't edit it. Maybe we open, is there a hello one? Yeah, okay. So if you change this code and save it, that will cause a cold start. That's one option. However, if you click the configuration tab and you add an environment variable, or you change the memory size, or you change the timeout, or you change the storage, that will also force a cold start. So what we're doing in the cold start benchmarker is forcing a cold start by updating the function configuration. So we have this conditional, which is if we want to force a cold start, we go ahead and make that API call using the AWS SDK. So it goes out to that function name and it just sets a random variable. So if we take a look, I'll show you what it looks like. So it's just got like a random, random generated string, couple characters, 5 characters. And you can see what that looks like on these functions as it runs through. We were doing the node dev, right? Yeah, we're doing node. Okay. So if we click through here, you can see set cold start and it's just some random variable. So that's how we do it. Yeah, good question. Thanks for asking. And yeah, hit that follow button if you want to hear more about serverless stuff, or you want to get questions asked and answered about your AWS account or how to learn AWS. I'm always happy to help. And then what we're doing is we're measuring the time it takes to invoke the function. So we have a start, right? And then we synchronously call the request response invoke method for that given function. And then we record the finish time. So it's not perfect. I think we could clean that up and maybe use like a closure to make that a little bit more consistent. But we have enough vCPU here that it should be, and it's the only thing running, so it should be very, very close to accurate. And we can see that already. It is pretty close. We get the response, we parse it, and then we stick that in a CloudWatch metric. We're doing that here. All right, so first things first, let's make sure this all worked. So we can check the logs for the invoke, and we should have a new one. So it's 3:30 here on the East Coast. Uh-oh, syntax error, unexpected token. Oh. So the bun responded. Oh, I didn't stringify this. Oops. Okay, so that's, I broke it. That's fine. We break stuff all the time. So let's open the index file. This is running in bun, and it should be what? It's like double encoded, right? Status code body. Yeah. Okay. Body. Okay, so we need new response. Not assignable to. Oh, because the response handler is modifying this. Okay. That's okay. I want to figure out what I'm logging here. Okay, so it already parses the result. The problem is that the keys aren't correct. That's easy to fix. So we have result, and then when we call parse.body, it doesn't exist. So it's no problem. JSON, let's stringify this, and then body. Oopsies. That looks good. Okay, rebuild this image, push it, retest it, should work. It's still gonna get the metric though. The nice thing about this is that the error, actually no, it's gonna choke on that one. Okay, that's why we don't see it. Never mind. We'll get it fixed. Deploy the function. You can do this all at once. The serverless framework allows you to build a container image and then deploy it at once, just like CDK or SST. If you want to learn how to do this, I really like the serverless framework. Also, definitely check out SST or the CDK. Dax, who you probably, if you're following Milky, you probably know who Dax is, works on that project. It's a good project. They've been working on it for a long time. They've solved a lot of the rough edges and hard parts about building serverless applications, so I think it's definitely worthwhile for you to check out. This is groovy. Yeah, I'm in the dev house. I'm in Melky's Discord, and I'm also in the watch.dev Discord if anyone has questions or wants to DM me. You can also DM me on Twitter. I'll drop that in the chat too. I don't have any account for it or any command for it. Like I said, I'm still really bad at Twitch. trying to get better. All right, here we go. Unexpected token, so it is just failing. Let's see when the last invoke went. Okay, so we got a double JSON stringify it. That's what's going on too, because it's going to grab it out and then expect that to be a JSON string. That's my own fault because of how the serverless framework kind of wraps responses. But that's fine. That's an easy fix. Yeah, I'm using so many services that are still in the free tier, right? Like I'm pushing a bunch of stuff to Amazon, like a private ECR repository, which holds your container images. I am deploying them into Lambda using S3 buckets, which is, you know, not free. But all this is not free to serve, but free to use. Well, we'll wait for this deploy. If anyone has any questions or wants me to talk about anything else about AWS or the Hero program, if you know about AWS and you want to kind of be more involved in the community, I definitely suggest you check out the AWS Community Builders program. It's free to join. You apply. I think it's like once or twice a year they open it up. I did that for 3 years before I became an AWS hero, and it's been really good to network with other people and see what other projects people are working on. They have like probably 5 or 6, big projects that they all work on together, and it's kind of neat. So if you want to learn more about the cloud, that's a great way to do it. They have people all over the world. Okay, that looks right, doesn't it? Handler TS. That should at least double parse the way that I've been doing it. So rare parrot. Oh, I need more emojis. If someone wants to educate me on Twitch emojis, I'd be really thrilled to learn more. I got an email today. I became an affiliate like this morning. They sent me an email, and no idea how to like what kind of emojis I should add or how I should do that. So if you have thoughts, reach out. All right, come on. Let's see if this works. Regarding Lambda, at what point should we... What? One quick question regarding Lambda. At what point should you switch from Lambda to EC2? You should switch from Lambda to EC2 when you have a really good idea of the throughput over time your application is going to have. So if you have a large enough deployment where Lambda is too expensive at scale, but you also are committed to auto scaling it yourself and supporting those additional requirements that come with owning a whole VM instead of just owning the Lambda function, that's when you should switch. I don't know if I would ever suggest going straight from Lambda to EC2. If I were you, I would check out AppRunner and Fargate. AppRunner is awesome. It's very similar, very, very much equivalent to Fargate, except you get a free load balancer. So when we talk about building high availability applications, and if you ever do a design interview, you're going to want to say, okay, so we have this let's draw the internet here as a circle. So these are requests coming in. When these requests come in, you don't just want it to hit your server, right? Because if they overwhelm the server, or the server is restarting your application, or you're adding a new server, you're going to end up not being able to serve traffic. So to be highly available, we add a load balancer. And there are a few things load balancers do. They're available in every major cloud. They typically terminate SSL, which means everything after here is plain text, which is fine because you're in your own virtual private cloud. They typically handle session stickiness, which means that you can hit the same worker, the same server that's behind the load balancer that you've hit over and over again, and that usually improves your cache hit rate if you have any kind of cache in your application. So what you do is you add a load balancer, which is at this phase acting as a proxy, right? And now you have, you know, VM1, VM2 or whatever, right? So then these requests get forwarded, and that means if you have to restart this VM, or you have to update it or patch that information, or patch that kernel or that system, or even just deploy a new version of your code, you can take this completely out of commission, and the load balancer will just route to the other machine. How I loved configuring HA proxy at Nginx. Yeah, and now everyone's on Envoy proxy. Envoy's like the fancy new one. Regardless, this is all built in for you with Lambda, which is one of the reasons why we like it. And load balancers, I think, are like $25 or $35 a month if you have like an IPv4 address, which can be spendy, right? Like if you have just a small application and you want high availability, you still need the load balancer there. So what you can do is then use App Runner, and App Runner gives you this for free and just bills you a little bit more in instance time for your application. So typically you can get a better monthly bill for the same high availability application using something like App Runner. You need this for Fargate too. You need like an ALB in front of it. So anyway, that's a quick run through of building high availability internet systems. Okay, now we have to figure out why this is failing. Unexpected token, U. So it's, oh. Yeah, I hope that answered your question, AKS. I'm trying to not break the types for Bun, but also not like replicate the exact same payload. We could also just try catch this. That would be fine. Yeah, why not? Let's just... Oopsies. I mean, you can decide based on throughput and cost. The downside of going with EC2 is that you have to figure out how much, like how it scales up and down. That's the big benefit of Lambda is when you have, like, just like this stream, I had 0 viewers before you all showed up. Thank you for coming by. But suddenly Milky hit the raid button, and then I had like 300 of you in here for a little bit. And when that happens, when you go from 0 to a ton of people trying to access your service, it's hard for EC2 to scale up ahead of time. So serverless doesn't bill you when it's not being called. That's one of the reasons we like it so much. So you got to be willing to capacity plan, and that means, you know, maybe running your application in Lambda for a year and seeing if you, especially if you're operating a service that will occasionally, or you know, have spikes in demand. Maybe it's, you know, it's fall, right? So maybe you're like an apple orchard, and no one's going to be trying to book an apple orchard tour in the middle of winter. However, in the fall, everyone's going to be at your website. So if you're willing to capacity plan and auto scale, or like scale for yourself, or set up auto scaling groups, that's a good time to go from Lambda to something like EC2. Okay. So we'll just do this. Let request to handler MS, and we'll just use the same. That should be fine. So I don't know why I broke this, but I broke it somehow. Oh, I think I actually know how. Yeah, so it's one key short. That's fine. I don't even need to fix it. We'll just, oh, there we go. Okay. So a deploy is going to cause a cold start, which means I get a new log group the next time this runs. Oh, at 45, right on time. Okay, there we go. Did it add bun? That's the real question. Bun. Hey, we did it. Okay. What did bun start in? Bun started at 382. So, okay, this is exactly what I want to highlight. 0 megabytes node function, 0 megabyte cold start. Round trip request time, 316 milliseconds. Bun, 0 megabytes, just bun, 382 milliseconds. So, are the buns warmed up? No, these are cold buns. These are unovened, unwarmed buns. Great question, Oddcast. Unwarmed buns. So that's actually right on track. Yeah, it's right on track. It's like 70 additional milliseconds of overhead for bun on a cold start. And that's only because we're packaging it as a custom runtime. So what I want everyone here to take away is if you have, a special runtime that AWS doesn't support, like PHP, for example, is a great choice. You can totally run it yourself and get really good performance. You just have to realize that comparing just the init duration in these logs isn't going to be enough. Oh, what did I do? Oh, a resource conflict exception. Oh, because I was deploying bun. Okay, so this is cool. I'm glad I got to show this off. So I'm trying to update the function configuration at the same time in my cold starter, right? Because we're changing that environment variable. We're just doing that in a loop to force cold starts. But at the same time, I was deploying a fix for that JSON string parsing problem. And what did we get? Well, we got a resource conflict exception. So no problem. This will go away in the next run. But let's go back to CloudWatch metrics. Now we should have 13. Graph metrics, 12 out of 13. Give me another one. Yes. Let's see. Bun. Put bun up there. Put bun on the menu. Bun. 245, 0 megabytes. That's not bad. There's nothing wrong with that. 245 milliseconds round trip time. Like just another, yeah, in this case, in this specific run, 100 milliseconds slower than Node 18. I mean, I think that's pretty reasonable. And these are round trip times, folks. Also, they're not just like cold start time. So when everyone tells you Lambda isn't performant, ask them to measure the round trip time of any of their requests. It's going to be 200 milliseconds or so. Check out Bun. Bun slaps. We should make a tweet about this. What's the best way to show this? Because I got a bunch of metrics here. I think I want to duplicate this. Let's just do 0 and bun. Come on, let me click. Good CloudWatch. All right. What do we? Okay, folks in the audience, you're all here right now. We have a choice. We have average and we have P99. We should look at both, but which one should we share with people? Because average is going to tell us we're always a cold start, so it's always a cold start, no question about it. P99 is almost the same. You think AKS P99? In this case, Bun is 4 milliseconds slower on P99 than just Node. P99 is typically how we talk about application performance. And the reason we do, if you're not familiar with this term, we should cover that super quick before I ask everyone, because I don't want anyone to feel left out. When we talk about application performance, we usually talk about it in terms of what are called quantile metrics. So the problem with average is that, as you have probably seen, in America, we have this crazy disparity of wealth. So like the average American, in terms of average, has some amount of money. Let's just call it like, it's ridiculous. The whole point is average covers up outliers, right? So if you have an Elon Musk who's worth, whatever hundreds of billions of dollars, like, yeah, that's going to skew the typical American family of four, who I think is like 65 or 55,000 US per year. So that's going to move that average way up, when in reality, the median or most commonly occurring value is probably closer to look at. So then what we do is break these into quantiles, and we say, okay, what's, the median, most commonly occurring value? That's P50. But then we also, when we're talking about application performance in distributed systems, what we typically find is that the curve is very, very, very long in terms of the performance curve of the app. Yes, exactly, standard deviations. But I want to talk about the extended performance curve of applications. So where's the DD sketch paper? Archive, here we go. Okay. Cite as, yeah, I know, I want the paper. No. Thank you. Okay, so this is a paper by Datadog, and it talks about how we are able to store histogram data very, very quickly in very small or sublinear space. So these are the standard deviations, or the quantile metrics, for a typical application. Maybe that web response can be rendered. Again, this is not round trip time like I'm measuring. This is like just the time spent on the server on the request. Maybe the P50 duration of a request is 50 milliseconds, say. And then P75 is 80, but way out here on P95, we have like 160, 200, 300, right? So it actually hides a huge amount of latency, because applications, when they tend to fail, tend to take a really, really, really long time on requests. And that's why we look at P99, because it tells a better story about what happens when things are starting to go wrong. This is a cool paper if you haven't read it. It is all about algorithms and data structures. If that's something you're studying in school, you may be interested in this paper. It's using a data structure called a sketch, and it optimizes for relative percentage, which means we can store a relative percentage error, which means we can store data about performance, like in milliseconds or any value, in buckets that are higher fidelity at the tail end. So because we know that there's maybe only one or two requests on this long tail that took 200 milliseconds, when we have millions and millions of points that took 50 milliseconds, 100 milliseconds or less, it allows us to store that in a space efficient way instead of having to store each bucket, which is typically how a sketch works. Anyway, this is great. We should tweet this. Oh no, what did I say? I have 5 notifications and I have very little followers. Building a new computer. All right, I have to think about this for a second, but I want to go back and see if we get more data here. Let's refresh this, because we should have a bunch more hits. Yeah, it's still, it's very consistent. We have, what, 4 points? 1, 2, 3, 4, 5 points already, and it's very, very, very consistent in terms of round trip time. Pretty awesome. Is that what we should say then? When measuring round trip time, considering round trip time for cold starts, Bun is much closer to node. Oh yeah, good call. Good call, yes. I should have. I don't. Do we? I need to read the style guide on this. And is a semicolon there? What do we think? Is that all right? Is that close? You think Primogen will click it? Probably not. I don't think Primogen knows who I am. Actually, that's for the better. That's for the best. Let's get some more data here and make sure we're not really, you know, wrong. AWS has a couple of leadership principles, and some of them I really don't like, but one of them I do is just try to be right a lot. And I really, you know, there's so much FUD in terms of cold starts on Lambda. So many people, if you mention the median, he'll come. So many people won't touch Lambda because they think this cold start is going to be a big problem, without realizing that there's so many things you can do about this and cutting these down and improving the performance, and B, so many people are talking about numbers that don't capture the whole picture, that I think they make uninformed technical decisions and as a result have bad experiences. And that's what I want to dispel with this talk. I'm not sure, is anyone in chat going to be at AWS reInvent? I'm guessing there's not a lot of overlap, because I think they're going to stream a lot of it. I don't think I'll get to stream when I'm there, but I might be on. Rafaz is going to be there? Okay, sweet. But this I think information will be a little surprising for a lot of people, but it's all open source. This is all open source. If you want to read this, if you want to replicate what I'm trying to do here, like this bun container, you can download this today and you can run AWS Lambda. You can run bun on Lambda and test this out yourself, like test out your application. You can do it right now if you want to. And again, probably totally free depending on, well, I imagine if anyone in chat probably doesn't have a million concurrent or a million invocations in a month already in their AWS account. But if you don't, it'll be free. Let this data just keep rolling in. This is awesome. We can probably fix that JSON parser thing quick. Did I fix it all the way? What did I think we have to do? We have to like wrap it again in something. Yeah, it's like status code. I think it'd be nice to see the round trip time, or not the round trip time, but the time to handler. Where is bun? Or did I already fix it and I just haven't? Oh, that totally works. I'd see an error there. Oh, maybe I wouldn't see an error there. No, it's too, okay, so that's wrong. First off, we should log that error. That is a mistake. Because I'm just catching this error and just dropping it on the floor. Let's make it short and sweet. And the difference between these two is that first off, there's a status code here, but you can see I've double encoded it in the wrong way. So we just want the value of the body to be double encoded and not the body itself. So I think we need these. JSON to stringify, JSON to stringify. What did I do here? No, it needs a JSON string. Do we clear this up? I'm lost on what's deployed, but let's... You can test this. Why don't we test this? Node, body, handler, TS. That's good, okay. So what if we also... Oopsies. I think it may need to be this. Isn't that what we had, though? I swear we just had this. Yeah, body call parse once and then parse event.body. That should be it. Let's see what the new error message is now that we're logging it. Let's see what we actually have out there. And yeah, if you're just swinging by, hit that follow button if you like the stream. We're doing all sorts of AWS stuff here. I'll be continuing to build serverless applications on this stream. That's the plan. Okay, it's like triple parsed. That's the problem. Yeah, so I don't think I want that. I think we want just this. Good. Docker. All right, I know that's a little cramped. Here, we'll fix it. Just rebuilding this Docker image and pushing it out. And then deploying the application. But we're still getting good metrics back, and let's triple check, but we are getting a response. So it's not erring, right? It is saying hello from Bun. And we can see we're getting tons of invokes. Yeah, like a cold start. Okay. If you want to check if a function cold started, check to see if a new log stream is created. So CloudWatch logs are delineated by log groups. A group is like a container or a bucket or a folder for log streams. Every time you see a new log stream, you have a new cold start. And we know this is working, so we know the cold starter is working, right? Because look at all of these. 54, 55, 53, 54, 5, 56, and so on and so forth. And it's running hello from Bun. That's great. And yeah, sure enough, look at that in iteration. Like, that's not bad. And this is true for PHP. I think if you want to, I mean, we could probably try it out, but with the advantages and the improvements that they made to loading container images on demand for Lambda, it's opened up this whole dimension of being able to run other runtimes and run other custom runtimes, or things that they don't necessarily support natively on Lambda. It's at least within the same realm or the same order of magnitude as everything else. All right, this is out. Let's see those logs. Do we break anything? Error parsing. Yeah, so it's like double encoded. Oh, I bet you it's because it's got a web adapter. Maybe that's why. Maybe the Bun runtime is like, it has to be a JSON string. Yeah, that makes sense. Okay, I think I know what's happening here. So when you're doing a direct invoke, it skips the API layer. Oh, Go-Cola, thank you for the follow. I appreciate it. Yeah, if anyone's still hanging around and wants to drop a follow before they bounce, I really appreciate that. Helps me out for sure. So that's what I think is happening here, because the Bun runtime is totally set up to be hooked up straight to probably an API gateway endpoint. So it's trying to cajole it into that response envelope, which I'm just not expecting, but I can fix that. Let's just remove the crap we don't need. Read-only headers. Yeah, Nicola, you're right. So they provide it, actually. Oh my god. They provided this themselves. So in the repo, they offer this for free. You can just download it. They show you how to publish this as a layer, but that's not the most performant way to run Bun in Lambda. So it should be a Docker container or a Docker image. And so I provided that all in GitHub. It's right here, Lambda Bun container. You can grab this now if you want. Oh wow, it's already got 10 stars. Holy smokes. So that's one of the things we did on stream last weekend. It is set up for you to get out and run. Right now it's just compiling the runtime and index file and returning this like hello world. You can put whatever you need to in here. Should we look at the last like 30 minutes. All right, so we got a couple of spikes here in P99. And that's true, like you're gonna have outlier latency. But if you look at like, yeah, P50, it's gonna be a lot smoother. All right. Boom, 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 boom. I guess not across the 1 minute, but anyway. So maybe this is maybe I'm glad we didn't we didn't yeet the tweet until we had a little bit more data. Yeah, I mean, even Node went higher than that. That's crazy. All right. Is time to copy a good word? You know what? I think that's good enough. Boom, boom, boom. This is great. Okay. Super good result. We added bun. Oh, I lost all my content. Yeah. That's great. So we've done this. This is awesome. Done that. Done that. We're automating it. We can add more container images, but I feel pretty good about buns so far. So I think that's a pretty good result overall. Pretty happy with this. Want to see if we got more data. In the last 45 minutes. Yeah, so it's going to always track that highest one, which is fine. Oh, and let's add the rest of these back in, actually. Boom, boom, boom. I wonder why we had a big spike in both of these startup latencies. So do we see this now right here? We had, in the last few minutes, we just had this like really, really big spike in both of these functions cold start times. And there can be a lot of reasons for that. I think probably the biggest reasons are you're building this on a giant distributed system with a lot of other customers, a lot of other users. So there's probably a bunch of other, intricacies here. Things are being assigned, workers are being assigned tasks to run, Lambda functions to run. They may be cycling in and out. They may be deploying new ones, adding different ones. You may have different hardware here. The network can be busier or slower. This is a really big impact on the performance of your Lambda functions. So I've said it before and I'll say it again. The key takeaway here are monitor the end-to-end latency for your application, whatever it is, Lambda or not, right? EC2 doesn't matter. There are a bunch of tools to do that, but that's what your customer's actually feeling and experiencing. So simply looking at what your server or your application says its response time isn't going to be sufficient, because you're going to end up missing additional overhead in either the network or the load balancer or something that may be between the user and you. You can do something like real user monitoring, which a bunch of a bunch of different services, including AWS's like CloudWatch support. So you can actually start injecting trace context in your application itself, right? So if you have like a Next.js app that's talking to Lambda, you can start measuring the duration inside of the Lambda function, and then inside of the application in React and Next. And then when that request is made and hits the actual Lambda function, it will just continue, and you can get like a full trace. And that's what we've kind of been doing, both at Datadog and on my blog when we talk about like measuring the impact of these applications. You have to really be thinking about end-to-end time, not just the cold start time, because these customer requests matter. You can kind of see something like that here. Cool. I feel great about this result. We are going to have to let this run for the next couple days. So it's just going to keep sitting here and polling for the next couple days. So we'll come back with some more results soon. I really appreciate everyone being here. This is so much fun. Thanks again, Melky, and everyone who rated. We're now going to jump into probably time enjoyed stream. But please hit the follow button if you haven't already. I'd love to have you back here and talk more about AWS and building applications of the cloud. Always happy to talk about career advice or, project advice, or if you want to talk about building more performant applications, you can always DM me or hit me up in Discord. Oh, thanks again for the follow, Tulrego. I'm sorry, I probably got that wrong. But I do really appreciate the time today, everyone. If you're going to reInvent, check out my talk. And otherwise, I'll see you in the next one. Thanks, friends. Love. Thanks, AKS. Yeah, nice and chill. All right, y'all. Have a great rest of your Saturday. Take care.
You just followed. Welcome in. How was your stream? I didn't know you streamed. AJ Stubenberg, let me give you a shout out. See what you were working on today. Introduce yourself. How long have you been streaming? What were you working on in software and game dev? Where are you from? I'm Time Enjoyed. I'm from California. I have budgies here. I paint budgies. I'm learning Python, working on my Django blog. Hanging. Oh, even this project. Let's see here. Website. You should make an account, Michael PC Gamer. Wait, what? My website link doesn't work? Oh, it does. And my internet might be slow today. Oh, AWS serverless stuff. Like for fun? What kind of serverless stuff? I see AWS as a tool. Is it for a personal project? So if you join timeenjoy.dev, it uses OAuth. You make a profile, you can make to-do lists, you can get tarot reads, they can get saved in the system. And with all the users that I have, I want them to like mark their Myers-Briggs personality type. That way I can do a mini data science here. I think that's what my idea from the beginning was. I just kind of like didn't do. Can I like URL list with template tags? Oh, I can. URL home. They're so noisy. It lagged out. Croden, is the game rigged? Croden stole your water? Croden, where's your plant? Oh, Croden's plant's doing well. Wait, did stealing the water actually water your plant? Because there's water on your plant right now.